Hi there. Welcome along to this session on bringing speech to your applications using the custom speech service. Today, I'm going to show you how to build a Skype bot that we can talk to just like we would talk to a person in the room. And this particular bot is going to have a special skill. It's going to be able to use the custom speech service to understand how to answer questions about dinosaurs. Now, I admit that dinosaur bots are not the most common industry scenario, but it is going to be a really interesting example of the power of the custom speech service. We're going to see how easily we can use this service to improve upon the standard speech recognition technologies available so we can understand and recognize some of those more complex biology terms. My name's James. I work for a technology consulting group called Zamata. We've been working very closely with the Microsoft AI team for the last few years. So it's very exciting to be here and kind of share some of the learnings that we've had working on this platform with you today. I'm also a regional director and many years ago was a software developer right here at Microsoft. Before we kick in and start talking about what the custom speech service actually is, we welcome your questions. So please send those through as we go. I'll do my best to answer all of them during the session. Otherwise, feel free to reach out to me online with the contact details on screen after the session as well. Right, let's talk about what the custom speech service is. Well, it's one of the Microsoft Cognitive Services. Microsoft Cognitive Services are a really broad set of RESTful endpoints that we can use to actually bring AI directly into our applications in a really easy way. And these technologies, these cognitive services, I think there are 20 or 30 of them now, they're grouped into various categories. So there are a whole bunch of services that are used for working with vision. There are more for search. There are others for knowledge. The ones that we're going to be talking about today, unsurprisingly, are the ones for speech. And there are 4 cognitive services that help us understand human speech. Now, 2 of these services aren't going to be super relevant for today. They're quite specific services, one for recognizing speakers and one for translating speech from different languages. The services that we're going to be talking the most about today are Bing Speech and, unsurprisingly, the custom speech service. So what are these 2 services? Well, the Bing Speech API is the general purpose speech-to-text model that is provided by Microsoft. Now, speech-to-text is basically taking an audio recording and turning that into text that our applications can work with. And the Bing Speech API is built on the same kind of technology that powers some pretty sophisticated applications at Microsoft like Cortana and Skype. Now, while that's all well and good, most applications don't actually require a general purpose speech recognition model. They don't actually need to understand every single word in the English language. What they really need to do is have a deep understanding of the kinds of terms that are actually going to be used by your application. So, it needs to understand all of those domain-specific terms. It needs to understand the instructions your users are likely to issue it. And that's where the custom speech service comes in. We're able to use a base model that Microsoft provides, a base understanding of a language, and then we're able to customize it. We're going to give examples of how our application is going to use speech recognition, and that's actually going to improve the quality and the accuracy of the recognition service. So there are 3 key areas that the custom speech service is going to help us with. So the first thing it's going to do is it's going to allow us to build a better language model. So to build a better language model, we're going to give it a whole bunch of examples of the kinds of phrases that our users might actually say to our application. And these can be full sentences, they can be fragments, they can be just individual words. So just by giving that kind of sample data, the model will get better and we're going to get better results with speech recognition. The next one is the acoustics. So we can actually provide it with recordings of our users speaking to our application and the associated transcript. So it can learn things like if your users typically have a slight accent when interacting with the service. If perhaps your users are working in a noisy environment like an airport or a factory, or one within an unusual acoustic environment like a car which might echo a little bit. So we can provide these recordings to the service and it can actually learn and improve its ability to recognize in these situations. And the last one is acronyms and pronunciation. We can actually train it to understand domain-specific terms and transcribe those correctly. And of course, this is all being built on standard models that Microsoft provides. So we just have to add a little bit of additional data. We don't have to train this from scratch. One of the most exciting things about this particular service is that it is actually API and SDK compatible with the Bing Speech API. So we can start with the Bing Speech API. We can start by using that in our applications, monitor the performance of it. And if we decide to need better accuracy, we can switch over to the custom speech service. And all we need to do is update some endpoints. All of our code will remain exactly the same. Now, one thing to say about the custom speech service before we jump into the code is that it is still in preview. So that means it's only available in one data center and language support is very limited at the moment. But that's pretty typical of the cognitive services when they're at this stage of development. The other thing to keep in mind is that by default, any samples that you provide to Microsoft through this service are going to be logged and used to help improve the quality of the service as it approaches GA. Now you can opt out of this, and I'm going to show you how to do this as we go through, but it's important to keep that in mind before you jump in. So how do we train a custom speech model? Well, it's super easy. It will take you about 10 minutes. So the first thing we need to do is prepare all our data. So we're going to prepare all of our recordings of our users. We're going to prepare the transcripts of those recordings, and we're going to prepare our language data. And that's just a text file of the kinds of things our users are going to say to our application. Now, at this point, I should point out that we don't actually have to do both, right? If you don't have a whole bunch of recordings handy of your users talking to your application, that's fine. Don't worry about it. We can just provide the language data. And conversely, you can just put acoustic data in if you don't happen to have the language data. So it's very easy to get started with this service. So once we have that data, we upload it into the web portal. We click train, and it's going to build a model for us. And then one of the great features about this service is that we can actually use the service itself to evaluate the accuracy of the model. So we can send a whole bunch of recordings through, and it can actually identify where it's getting the words wrong, which is fantastic for us as developers because it allows us to identify areas where we might need a little bit more training data, or perhaps we need to change some of the phrases that are used to invoke our application. And then finally, once we're happy, we can deploy it. We can actually push this out as an endpoint, and then we can just plug those endpoints into the SDK, and away we go. Right, with that said, that is all of the slides done. We're going to spend the rest of the time in this session in Visual Studio, and we're going to look at how we build our Skype bot to answer all of our questions about dinosaurs. Let me switch over to the demo machine, and we're going to start by having a look at how to build a custom speech model. So to start building a custom speech model, we're going to go to the custom speech portal, and it's actually named after its old name. So the portal is CRIS.ai, CRIS.ai, and that's the Custom Recognition Intelligence Service. So that's the old name for custom speech service. So you'll see CRIS in a lot of the documentation still as they update it to its new name, the custom speech service. So I'm going to sign in here. And the first thing that you're going to get, if you haven't used this service before, is it's going to prompt you for a key. It's going to prompt you for a subscription key. You can get to that same page by just dropping down your name and going here. You can see all my keys here. I promise I'll invalidate them at some point, so don't get too excited. Here are the keys that I've already registered. Now, how do you get a key? Well, we can get keys from the Microsoft Azure portal. So if we switch over here, we can type in custom speech. And this process is exactly the same for all of the cognitive services. We're going to select custom speech, and I'll just zoom in there, you can see it. Just zoom in there. So there's custom speech as the service. We'll select that. And creating it is super simple. We just have to give it a name, a resource group, select the pricing tier. Quite nicely, there is actually a free offering, so you can actually get started without having to pay for anything. And then you click OK, and it will provision and create a key. Fortunately, I've already done that. Let's go and have a look at one of the keys that I've created earlier on. So this is just the standard cognitive services interface that you'll find in Azure. If you click down to keys, you'll be able to see both your primary and secondary key and the name of your service. So we copy that, we paste it into the CRIS portal, and now we're ready to go. Now, what's next? Well, there's this menu up the top here called Custom Speech with a little drop down. And that's going to guide you through the whole process of setting up your custom speech model. And the nice thing about this menu is it's basically ordered correctly. If you go from top to bottom, you'll end up with a nice custom speech service. So the first thing we're going to do is upload our data. So we have 3 different types of data, and you'll see that I've already prepared this in advance. So the first thing we're going to do is upload an acoustic data set. And let me show you what an acoustic data set actually looks like. An acoustic data set is a zip file. It's got a whole bunch of wave files inside of it. And if I lean down to the speaker here, I'll play one for you.
What dinosaurs lived in the late Cretaceous era?
So that said, what dinosaurs lived in the late Cretaceous era? So that's a recording using some technical or some specialist terms there. So that's part of the acoustic data set. So I've got a whole bunch of recordings, and I've also got some transcriptions. So if I open up the transcription file, it's just the name of the recording and the transcription of that recording. So that's the acoustic data set. So we can create those pretty easily. Let's switch back to the browser. We can have a look at that. So we give a name, we upload our transcriptions and our audio files, save that, and we now have an acoustic data set. The next thing that we want to do is upload a language data set. And the language data set is just that all of those kind of sentence fragments, full sentences, words that our users are likely to use with our application. So this one's a lot easier to come and pull together compared to what we saw with the acoustic version, which requires recordings. So here's all the language data. I've got a whole bunch of different things that our application might say. So there's a whole bunch of different terms here that the service can learn from. And then finally, I've got a couple of pronunciation guides for the service. So these are for a couple of acronyms that our service might use. Now, for those that are eagle-eyed here, you'll notice that these are in fact Star Wars acronyms. They do illustrate the capability quite nicely, but probably not terribly relevant to our biology and dinosaur scenario. So I apologize for that, but my knowledge of biology acronyms is a little bit lacking. So we've got C3PO here, so we've actually just spelt it out for the service. So if I say C3PO, it can actually recognize I'm not saying individual words, I'm actually using an acronym there. Great, so let's switch back to the portal. So that's the first step. We've uploaded our data sets. The next step is to build an acoustic model. And this is optional, right? If you don't have recordings of your users, don't worry about it. We can still create a custom speech model just from language data. So what do we do to create an acoustic model? Well, we're going to select the data set that we just uploaded. We're going to select the subscription key that we want to use. And this is one area which is a little interesting, is that we get to choose a base model. So this is the model that we actually build on top of. This is the one that Microsoft provides us, and then we can customize. And there are two. There's the conversational model, and this is optimized to transcribe people talking, right? So this is a particular style of conversation, a particular type of sentences and language. The other one is the search and dictation model. And this is really ideal for when your users are issuing commands to your application. So for our purposes, search and dictation is really what we're looking for. We want to build a model that is going to receive commands that users send to our application, rather than, for example, transcribing the notes of a meeting. So we can select that, we can select our data set, we can give it a name, and we can even enable accuracy testing right here. We'll actually talk about that separately in just a moment. So creating an acoustic model, even with a small data set, will actually take a couple of minutes. So we're going to avoid doing that right here live, so we can make sure we finish roughly on time. And instead, jump forward to the language model. So this is uploading all of those sentence fragments up to the service to understand a little bit more about the kinds of terms our users use. And you'll actually notice that the form to create this is actually very similar, right? So we have the base model, so it could be a conversational model, again, for people talking, versus a search and dictation model for people interacting or sending commands to our application. So we pick the right base model, we pick the language data, we optionally add in some custom pronunciation or the acronym data set, select our subscription, and it starts importing and building that model. So if we go back to that page, you'll actually see I've already got a language model here. I trained that a wee while ago. So I have my acoustic model, I have my language model, and now I can test these models. So if we go down to accuracy testing, and this is a really cool capability in this service, because if you're building your own models, well, you need a way of identifying whether they're any good or not. And that's what this provides. So I can select a subscription, I can filter the models that I have by type, and here I've got the biology acoustic model, the biology knowledge model, and I can actually pass it a data set, and it can process all of those samples and figure out which ones it gets right and which ones it gets wrong. So if I actually switch over here to accuracy tests, I ran this a little while ago, I can bring this up, I can see the word error rate of my custom model. So as I collect more data over time, I can actually see whether the models that I'm creating are actually any better than previous models. And then I actually get the transcription output for every single recording that the service pushes in. So I can actually see exactly how my custom model transcribed a particular recording, which is super useful to identify where perhaps the service isn't doing so well. So once I'm happy with my model, I go to the very last step. So I've got my language model, I've got my acoustic model. Word error rate looks great. Let's turn this into a web service. So again, pretty simple process here. I select my subscription key. This is where I can opt out of any logging if I want to. I'm going to pay a little bit more, but if I don't want those recordings that I'm submitting to be maintained by Microsoft for the purposes of improving the service while it's in preview, I can uncheck that. And then I just select the models. So I base both of my models on search and dictation, so I'll select that, and then I can select both the acoustic and the language model. I have one that's already out there. Here's my endpoint. If I go and have a look at the details, you'll see that I get all of the information that I need to call this service. So I have the subscription key, I have the HTTP endpoints, I have the WebSockets endpoints, and I have even the ability to test these new endpoints right from the portal here. So let's actually do that. I'm going to play you a little sample WAV file.
How tall is the Styracosaurus?
So that's me saying, how tall is the Styracosaurus? And I'm going to upload this. I'm going to click test, and we can see that the recognition result comes through right there in the portal. Very easy to make sure that things are up and running nicely. Right, so that's step one. We've created the custom speech service. The next thing that we're going to do is actually figure out how to answer the questions, right? So the custom speech service is going to be really great at recognizing all of these weird biology terms, but how is it actually going to know the answer to the questions that I'm about to ask it? And for that, we're going to use a service called Q&A Maker. And Q&A Maker is a really easy way to build a knowledge base from existing data. So I'm going to call this one Connect Demo Friday. And I'm going to select an existing data set. And I can select data sets from a whole bunch of different locations. I can point it to my public-facing website, and it can scrape the data from there. I can provide it with PDFs, spreadsheets. Today, I'm going to provide it with a TSV file. And I'm just going to open that so we can all see what's in here. So this is tab-separated data. So basically, I've got the questions that my users might ask on the left and the answers on the right. I'm going to select that TSV file, and then I'm just going to click Create. It's going to import all of those Q&A pairs into the system. I can then go in there and edit any of these Q&A pairs that I want to. I can provide alternative phrasing. I can provide alternative answers. I can test this service. And then we can actually see that in action from the portal here. I can actually start to interact with my knowledge base directly. Now, a couple of good questions here that I've just received about the custom speech service. Now, is there a way of building the model dynamically? Not at the moment. I'm not aware of any features like that at the moment. So what's happening right now is that you would be responsible for recording and tracing any data that your users, obviously with the proper consent, and then using that to improve the model in the future. There's nothing that's automated at the moment. Now, there's a couple of reasons for that, and the main one is that more data doesn't necessarily mean you're going to get a better model. So there tends to need to be some kind of manual intervention, some kind of manual evaluation of this new data and how it affects the model. So while a fully dynamic service is probably unlikely, if you look at some of the things that other services do, like Lewis and the custom vision service, simply collecting that data and feeding that into model so you can evaluate the performance of models based on this new data is certainly something that's worthwhile, and perhaps at this point, something that you'll need to build yourself. Now, does it help with, another question, does it help with accents like New Zealand or Australian? Well, that's a good question. I haven't actually trained the service with a whole bunch of data from my specific accent, but yes, in general, yes. So if we can provide it with samples of people with accents or samples of people that are in noisy environments, it will improve the quality of the recognition. Now, what it won't do is understand a completely different language, right? So it is still going to be based on English. It doesn't allow you to, make up words and recognize them. It just helps the existing model to recognize existing words a little bit better. Right, 2 great questions. Thanks. Keep them coming. If I didn't manage to answer those to your satisfaction, just ask them again, and we'll come back to them. Right, so here's the Q&A maker. We're back here. We've got our data set in there. And if we just click Save and Retrain, that's going to take all of those Q&A pairs that we've already got, build a model out of it. We're going to publish this. And the really cool thing about this model is that we don't have to be specific. We don't have to ask the exact question that is in the Q&A knowledge base. The Q&A knowledge base is actually smart enough now that it's based on a model that it can actually map the best answer based on the question. So I've deployed the service. As you can see, that was a super simple process, right? I imported my data set, I click train, I click publish, and now I have a service that's allowed me to answer questions. Right, the last thing that we're going to do, so we've created the custom speech service that's going to allow us to recognize these technical terms that our users are going to send to us. We've got the Q&A maker that's going to allow us to actually answer the questions that folks send us. The last thing we need to do is to create a bot service, and that's actually where we're going to host our code. So to do that, we're going to come back into the Azure portal. We're going to type in bot service. We're going to select bot service from the list of available offerings from Azure here, and I'll zoom in here just so you can see the different options as it loads up. So the first thing is that the bot service is a mashup of the Microsoft Bot Framework and Azure App Service. And hopefully this will load, but I've been through this enough. I think I can probably talk to what's on the screen, even if it doesn't. So you need to make a couple of decisions to provision your bot service. The first thing is you need to give it a name, and as you'll see in the window here is that it's actually a DNS name, so it needs to be globally unique. The next thing you need to do is create a resource group or use an existing resource group. And then finally, you need to choose how you're going to host it. And we're going to talk a little bit more about hosting in the next session, so you should totally stick around for our session on the bot framework and Cortana skills. But you basically have 2 choices with hosting. One is that you can host on an Azure web app. So that means it's a very traditional hosting model. You can create VMs, you can deploy to that, all managed by the app service, but you are provisioning hardware. The other one is called the consumption plan, and the consumption plan is actually based on Azure Functions. So it's actually dynamically compiled C#, and you only pay for when the bot is actually working. So the simplest option here for us is going to be using an app service plan. So that's what I've prepared and built. And in fact, to save us a little bit of time, I've actually gone through that process. I've downloaded the default code that the service provisions for us, and I've set that up here on my machine, and we're going to walk through it. I've pre-staged a little bit of the Skype code, so there's a little bit of extra code here, but all of that code is available on the documentation site for the bot framework. There's nothing particularly special that I've added in there. So the next thing that we're going to do is take a look at a very simple starting question. And that is, how do we push in data from an audio file? We're not going to do anything fancy. We're not going to do like Skype, interactive speech just yet. We're just going to submit an audio file. We're going to transcribe that audio file, and we're going to pass that transcription off to the Q&A maker so we can get a response back. So it's keeping things super quick, super simple. So I have another question here, so I'm just going to pause for a moment. So is it possible to feed the model in dynamically by pulling models and pronunciations from a database? Great question. In terms of language data, in terms of pronunciation data, all we're doing is uploading text files. For language data, it's just a phrase on a new line. So all of that data is something that could conceivably be posted up quite easily. So we could extract it from a database, put it into a text file, and post it up. In terms of a full end-to-end automation integration solution with a database, not right now. But again, this service is in its very early preview stages. So I think this kind of feedback is exactly the kind of feedback that the product team will be looking for. So great to have this coming through today. Figuring out what the production workflow looks like for these services is really important, as we've already discussed. So if we think that databases is a key feature, then we should definitely feed that back through. So thank you for sharing that. Right, so let's flip back to Visual Studio. And what I've done here is super simple. What I have taken is just the standard code from the bot service that gets provisioned by default. And I've added in just this snippet here, and I'll in fact zoom it in so you can see what I've done. So what I've done here is I'm taking an attachment that I've received from the bot chat. If it's a if it's an audio attachment, then I'm going to take that audio, I'm going to send it to the Bing speech service, I'm going to send it to the custom speech service, and then I'm going to output that into a debug channel and then send it off to be answered by the Q&A maker. So the interesting thing here is that this is not something that you would typically see in bot code, right? This is just a super simple way for us to get started. And we're going to see how we can turn this into a fully interactive Skype bot in just a moment. So let's go and take a look at how we do that interactive transcription of our audio recordings. So there are two things that you're going to need to do. The first thing is that you're going to need to get a token to actually access the service. And I should point out before we go too much further, I'm calling both the Bing speech service and the custom speech service. You would do one or the other in a production scenario. However, I'm doing both so we can see the relative performance of these two services side by side. And it's also going to allow you to see how I'm using exactly the same code in both situations. So let's go and have a look at this snippet of code here, this particular one here, in fact. So this is getting the token. So basically what I'm going to do is I'm going to take the key that I got from the Azure portal when I created a Bing Speech API key, just like any other cognitive service, and I'm going to post it up to a token URI. And that token URI is going to return me, as you might expect, a token. And that token is roughly available for 10 minutes or so you can quite safely cache that. And then you use that token when you're interacting with these services. So there's kind of those two steps. First, you take the key, you turn it into a token, and then once you've got your token, you can work with the service. So let's go and have a look at the transcription here. And this is the code to actually take the raw audio stream and turn it into text. And interacting with these services via HTTP is actually pretty simple. There's one major limitation to keep in mind, and that is you can only send up to 15 seconds of a recording via HTTP. I'm going to show you how to get around that in just a moment, but for HTTP it's 10 seconds, which is typically, 15 seconds, which is typically what is required if you're just sending a command to an app. You know, hey Cortana, book me a ride to the airport, right? That's more than enough capability there. A couple of gotchas: make sure that you enable transfer encoding chunked, set that one to true. Make sure you have the right content type header on the message that you're sending up. But aside from that, there's very little else to make this work. So I'm just going to comment out this exception here, make sure that other one's commented out, and we're going to spin this up. We're going to see it in action. And to test this locally, I'm just going to use the Bot Framework emulator. And the Bot Framework emulator is a simple app here, and all I need to do is enter the endpoint that IIS Express is going to post for me. So I'll type that in. I can leave both app ID and password blank, and click connect, and in just a few moments, once my service spins up, I am going to be able to get a welcome message and then start uploading my audio files and see the transcription. And in fact, I'm going to send the same audio file as what I sent during our model training exercise on the website itself. So let me just upload that upload that file. So here I'm uploading the sample wave file. We're going to pass that both to Bing Speech and our custom speech model. And if we zoom in a little, you'll be able to see that there's actually quite a difference in the result, right? So Bing says, how tall is the saurus? Chris, or the custom speech service, correctly recognizes it as how tall is the Styracosaurus. And then you'll see the bot also responds, and that's using the Q&A maker. And you might be saying, oh, I missed that. How did you make the Q&A maker work? Well, I apologize, I did miss that out of the intro there. Let's go and take a quick look at how the Q&A maker was actually integrated into our application. Prepare to be underwhelmed because it's super simple. So the first thing that we need to do is install this package here called microsoft.bot.builder.cognitive-services. Now this has a whole bunch of nice helpers to integrate Q&A Maker directly into our application. So to create a Q&A Maker dialog, we inherit from Q&A Maker dialog. So I've called mine basic Q&A Maker dialog. And then we have to pass it the Q&A subscription key, the Q&A knowledge base ID, that's the knowledge base that we built online, and that's it. That's all we need to do. If we pass text to our bot now, it will automatically be sent in every case off to the Q&A Maker. It'll look for the best answer and then respond. Now, there are a bunch of additional things we could do here. We could adjust the tolerances for matching to, questions to answers. We can adjust the response when the bot doesn't know. We can potentially forward, in that case, off to a different dialogue. We can combine this with other bot features as well. But just to do a Q&A bot, it is very, very straightforward. And if you have a look in the messages controller, just down here, you'll see that when we start the conversation, we just have to create an instance of that dialogue. And if you want to learn more about dialogues, then again, stick around for our next session. We're going to talk a lot about the bot framework in a little more detail. So we have now a very, very simple bot. We can upload it a WAV file, and it's going to tell us what's in that WAV file, send the question off to the Q&A Maker, and get a response back. What do we do next? Well, before we go any further, I'm sure positive some of you saw this little icon in the bottom right here with this little speech thing. And you might be thinking, well, why aren't we just using the speech icon, right? And that's a great question. For a number of the bots, channels, speech is actually built into the platform. We don't actually have to, record a WAV file and upload it. We can actually just naturally interact with it. And for this particular control, that is the web chat, if you provide it with the necessary keys, you can in fact get the bot chat control to handle all of the handshakes with Bing Speech completely transparently. Now, for our purposes, we really wanted to see the CRIS, or the custom speech service, in action, so we're going to take a slightly different approach. And for Skype, once we actually get our working Skype up and running, well, that doesn't quite actually support this kind of speech-to-text transcription. But I just thought I'd mention that in case you did see that as we were going along. So that is using the HTTP endpoint. And if you look at the code, it's less than a screen at quite a high resolution. It's pretty straightforward, and you might be wondering then, why do we have these SDKs, right? So we have a couple of SDKs for Bing Speech, and because it's API compatible, also for custom speech. So why do we have these things? Well, there are a couple of limitations, and I've mentioned one of them already about HTTP, and the major limitation about HTTP is that it's limited to 15 seconds of transcription. But it also misses a couple of other features that you'll get if you use the SDKs, because fundamentally the SDKs are actually using a WebSockets protocol rather than just a RESTful interface. So the WebSockets protocol unlocks a couple of other interesting features, like it can detect when people have finished speaking. It can enable you to do lower latency transcriptions, because it's actually it's a two-way connection that's always open. And finally, and I think most excitingly, you can do partial transcriptions, which I'll show you in just a moment. So what does it take to switch over and use the SDK? Well, the first gotcha is that there are two. One is called Project Oxford Speech Recognition, so Microsoft.projectoxford.speech recognition, and the other one is called Microsoft.bing.speech. These are very different SDKs, and they have very specific purposes, and it's important to get them the right way around. So if we have a look at this one, this class here, I'm actually using the Microsoft.projectoxford.speech recognition SDK. And this SDK is designed explicitly for client scenarios, right? So I'm building a WPF app, and I want to be able to do speech recognition on the client in .NET code. If you use this on the server, it doesn't work particularly well. There's some weird kind of slow disposers, and I can attest to that because I have in fact tried to deploy this on the server, and it doesn't work out very well. So make sure you pick the right one. So this one is great if you're running in a desktop app, but if you want to run on the server, there's a different SDK. So we're not going to spend a lot of time here because obviously we're building a server-side application. Not a lot to point out, aside from the fact that we subscribe to a couple of events to get the data out, and then we start pushing the data through the WebSockets connection. until we finish. The more interesting one for us is the server speech service, and this is using the Microsoft.Bing.Speech SDK, and this is the one that you're going to want to use if you actually want to do server-side speech text. So what's involved here? Well, you're going to be unsurprised because it's actually very similar to working with the HTTP endpoint. The first thing we need to do is get that token, and to get a token, we need to implement an interface that's actually part of the SDK, and it's called iAuthorization Provider. It's part of the Microsoft Bing Speech SDK. So I implement that, and I need to implement the specific method called getAuthorizationTokenAsync, uncomment my code. And if you've been following along closely, you'll actually notice that the code that I'm using here is exactly the same code as what I used when I got the token for the HTTP implementation of this. So it's exactly the same. I take my key from the Azure portal, I post it up to the token endpoint, and I get back a token. Super easy. So that's step one, and then the other step is just to call into the SDK. Now there's really only one thing of particular note in this SDK invocation. Let's bring that back. And it is async await kind of compatible, but it has this recognize method that we can pass our stream into, but it doesn't actually return anything. There's no, it's just returns a task. There's no data coming back from that. So to actually get the transcription, we have to subscribe to these events. So it's a little bit of a unusual programming model for those that are familiar with async await. We actually use events as well as async await. So there's a whole bunch of metadata that the SDK requires in terms of what kind of device are you using, what kind of application are you building. So we can configure all that. We pass in the auth provider up here. You can see up in the preferences that we pass to the SDK, which is the speech client. We pass in the language that the user is speaking, the endpoint URL, and both the key and the token URL to the auth provider, which we just had a look at. So let's go and have a look at this in action. The last thing I'm going to just mention before we see this work again is that you'll see that I've got these two methods, create Bing and create Chris. And if we go and have a look at what those look like, you'll see I'm passing in the URLs and the keys that are specific to each of these services. All of the code that actually gets executed, this code here, is exactly the same for both services. As we've described, they are API SDK compatible, which makes them easy to work with. So when I need to set these up, I need to provide the right URL for doing transcriptions. In this case, I've got a WebSockets one. This is a well-known one because Bing is not customizable. For this Chris version, I actually get that URL from the Chris portal for my particular model, my particular deployment. Then pass in the key for both. This is just the key from the Azure portal. And then finally, I pass in the token endpoint. And there's a slight difference here. We've got a generic token endpoint here for all cognitive services, really, here. And then the other one is actually specific to the WestUS data center for the custom speech service. And that's because the custom speech service is only available currently in the WestUS data center. So with that in place, we can spin up our service again. We'll submit exactly the same audio recording of me saying, how tall was the Styracosaurus? And we'll see how the transcription looks. Start a new conversation up here. Wait for the service to spin up a little. And upload that file again. Great, so we're getting a very similar result. And then we get our answer back from Q&A Maker. Now we've just got a question come in. Can you chain questions? In the case that the second question depends on the answer to the first question. That's an excellent question. No. So the Q&A Maker is exactly what I showed you today. Questions and answers. There's nothing more to it than that. So if you need to clarify the user's intent, if you want to walk them through a flow, then we're more likely to flip over and use the bot framework instead. And that's what we're in fact going to be talking a little bit more about in the next session. Great question. Yeah, so Q&A Maker is exactly what it looks like. Question, answer, nothing more to it than that. But the bot framework has a whole bunch of really great conversation flows. It is going to require a little bit more work to build those, but you can do much richer interactions that are stateful, that they are, they are aware of the context of the conversation before responding. Cool. So we have our emulator still up on screen. We can see that it's all worked. We've switched over. The last feature I want to show you about the SDKs and the WebSockets approach of doing things is partial results. So I'm just going to uncomment this. That's just going to subscribe to another event. Now, if you've ever used things like Siri or Cortana or Google's Assistant, you'll be familiar with this concept of partial translations, because it's as you start to speak, you actually see the words start to appear in the text box on screen. And sometimes you'll even see it correct itself. As you continue to speak, it'll figure out that it's picked the wrong word, so it'll go back and erase and try again. And that's exactly what the WebSockets API actually allows you to do. So this would allow us to build quite rich interactive experiences with our client-side apps. Now, it doesn't really apply in this scenario because the chat emulator doesn't really give me any way of returning partial transcriptions or visualizing them. But I have written these partial transcriptions to output, to debug output, so we can at least see what experiences we might be able to build here. So I'm going to pass through exactly the same sample data file. Now it's going to spin up the back end, send that off to the two services. Great, I get exactly the same result, but here's the interesting part, and I'll zoom in because this is pretty small. You'll actually see that as I submit that very short sentence, I actually get 8 partial translations. So this is kind of coming in near real time back to the client. So you can actually provide a super rich interactive experience with your speech-to-text interfaces, thanks to the WebSockets capabilities that are available through the SDK. Right, okay, so that is our very simple bot. We can upload an attachment and it will transcribe it. Well, as we pointed out, that's probably not a terribly useful service. Most users aren't going to want to record themselves and then submit that as a file. So let's go and take a look at what a real bot might look like. And a real bot, in this case, is going to be our IVR bot in Skype. And let me show you some of the code for that. So the main code for that is actually entered through here. We've got a new controller, one for the initial call coming in, which is the second one here, and one for the call events, so as the call is continuing. And we actually register the calling bot globally up here, which is the IVR bot. So let's go and have a look at what the IVR bot does. The IVR bot implements this iCalling bot interface. And the interesting thing about this is actually taking this iCalling bot service and subscribing to the interesting events so we can react to them. So this bot is very much like those kinds of automated bank systems that you might be familiar with, where you can speak or say what you want to do at any one point. And thanks to the custom speech service, it's a whole bunch more accurate than what you might be experiencing with line of business kind of banking systems. So I've attached to a particular event here, which is going to be the on-record completed event. So this is actually when somebody has finished speaking. We're going to get a recording of what they've just said. And if you can have a look here, you'll see some very familiar code where we actually transcribe both of those things. So we take that recording from Skype, we send it to both Bing and to Chris. And again, we wouldn't do this in production. We'd use just one or the other, but this allows us to kind of compare the results. So we send both of them up. We're going to log out what both services thought, what their best guesses were, and then we're going to send that message over to the Q&A maker. And if we scroll down a little bit further, we'll actually see that in action. You'll see that I have the Q&A service. I pass in my subscription ID, my knowledge base ID. I wait for a little bit to simulate the human response. I take that answer that's returned, I speak it back to the user, and then I ask them to ask another question. So all of the code here for this IVR bot is available. It's part of the bot framework documentation. I've had to do very little from that boilerplate code to actually wire this up for my scenario. Right, so I have my code ready to go. How do I get that into my bot service? Well, today we're actually going to use Git we're going to use git deploy. And let me show you how I can do this. Now, you might remember when we were talking about the bot service, I said it was just a completely standard Azure app service. And it is. So we can use all of the same cool deployment options that you're probably familiar with if you've built web apps on Azure before. So you can do things like Visual Studio integration, Visual Studio Team System, more specifically integration. You can synchronize with your Dropbox if you really want to. There's a whole bunch of different integrations, including GitHub, that we can take advantage of. So here's my bot here. This is what you get once you've finished provisioning. If I switch over to advanced settings here, you'll see that I can pick up the git clone URL. I'll zoom in so that's just a little clearer. And this is the URL. I can just add that to my command prompt as a Git repository that I have access to, and I can just push my code up that way. So it's a super easy way for me to deploy and get data into the cloud quickly. The other thing that I will point out is that if you want to do an IVR but for Skype, it's not actually enabled by default. So this is kind of an advanced setting for Skype. So if I want to enable an IVR but, I have to come here to channels. I can see Skype is already enabled, but I'm going to have to edit that. I'm going to have to enable a couple of additional features. So if I go into calling, I have to make sure that calling is enabled. I have to make sure that it's IVR calling, and I need to provide a URL back to that calling endpoint that we saw just before in the calling controller. So where do we hit? What endpoint do we hit to get this triggered and moving? And that's about it. So let's do that, in fact, and we'll see it in action. So if I go back to my command prompt, and I'll zoom in so you can see what I'm doing in just a moment. So what I've done here is I've just checked what's changed. I've added them into a change set. I've made a commit. And what I'm going to do is push this branch to Azure. So if you have a look down here, I've got a local branch called Connect. I want to push that up to the remote master branch. So that's what that little slightly unusual syntax is. I suspect it's prompting me for a password. Oh no, here it goes. So if you haven't seen this in action before, what it's actually doing is it's just publishing the code diff. So it doesn't have to upload or build anything locally. It's just the code that's changed from the last time I deployed. It's then actually going to kick off a build process. It's going to do all my NuGet restores and deploy the new web application into IIS. Now, one thing to note is that I've actually got a couple of CSproj files in this solution. So the one thing I did have to do to make this all work nicely is tell it which CSproj file to actually build and deploy. And I can do that super easily by just specifying this project key in my app settings. So I just provide it with a path to the CSproj that I want it to build and release. So hopefully at this point, we can see that it's finished building. It has deployed the code into our production environment. So there's nothing left to do but cross our fingers and give it a call. So let's switch over to Skype. And here we go. Here's my Connect Chris bot. And this reminds me, you're probably wondering, how do you get that bot into your Skype environment? Great question. This took me a while to figure out, so I would like to share it with you. And that's the Skype link here. So this, as you might perhaps expect, doesn't actually take you to the edit screen. This actually takes you to the join screen. And if you copy this link, it's actually a link to add the bot to your Skype account. Now, if you click here, if you just click immediately, it's going to add it to whatever account that you're already signed into with Skype, which may actually be a different account. You know, for example, here I'm using my corporate account. So you can copy this link, make sure you're signed into the right Skype account on the web, and then paste it in, and it'll appear in your Skype apps. Now, you can distribute this link, and you can add a number of different people to your bot. But at some point, and I think it's around 100, I have to double check that, there will be there is a limit. And if you want to go beyond that, you actually need to publish your bot, which just takes a little bit of paperwork, and then it's available to the world. So with that said, we can see the bots in my Skype environment at least. Let me give this a call.
Hello. I'm the Biology Knowledge Bot. Ask me a question.
How tall is the Styracosaurus? Now this actually takes a few seconds. It's going to spin up. It's going to call a bunch of different services. So we shouldn't panic just yet if it's going to take a few seconds to respond.
It was 80 centimeters tall. That's 31 inches. Ask me a question.
Goodbye.
Thank you for using the Biology Knowledge Bot.
Right, so I didn't want to interrupt it there. So let me just take you through what we just saw. So the bot picked up, it asked us to ask it a question. So we asked that question, we said, how tall is the Styracosaurus? We see in the chat, and this is kind of effectively debug output, but we see in the chat what the Bing speech service provided back to us, which was how tall is the Saurus. And we also saw what the custom speech service returned to us, which is how tall is the Styracosaurus, which is correct. It then passed both of those recordings off to the Q&A maker, got the right question and answer pair, returned the answer result, and it spoke it back to us, and then asked for another question, at which point I said goodbye, and it hung up. So let's just switch back to the slides, and we'll wrap this session up. So we saw how the custom speech service was something that we could actually put together and start using within an hour. We were able to upload our source data files, we were able to train a model, publish it, and then we were able to use the same SDKs that we were already using to interact with Bing speech service. If you're interested in trying this out, I wanted to share a few links with you. The first one is, again, something that I've only recently found out about, but you can actually try a number of the cognitive services without having to sign up for like a full Azure subscription. So check out that first link there, which is akams/trycs. All of these sessions are going to be available on demand, so please check them out on Channel 9. And then finally, there's a new resource that Microsoft has recently released called AI School. And these have a whole bunch of really great learning paths for getting deep with some of these topics. So I'd encourage you to check those out. If you've got still questions about the bot framework, there are some really great resources on the bot framework available through the AI School. So thank you very much for tuning in. I hope you found this session useful. Feel free to reach out in the comments afterwards if you have questions, or reach out to me directly on Twitter. I hope you'll find that the custom speech service benefits your applications as much as it has for us. Thank you.